Today we are going to be learning about graphing of exponential functions. Exponential functions have a form similar to g of x, in which the base is a constant and the exponent is a variable. So consider the function g of x equals 3 to the power of x, in which 3 is the constant and x is the variable. The key concept here is an exponential function, base b, has the form f of x equals a times b to the power of x, where x is any real number and a and b are real number constants, such that a does not equal 0, b is positive, and b does not equal 1. Examples include f of x equals 4 to the power of x, 1/3 to the power of x, and 7 to the power of negative x. Non-examples include 2x to the power of negative 3, 5 to the power of pi, and 1 to the power of x, in which all do not have all three properties. Roots for the function f of x equals 4 to the power of x are just plugged in as such. So if f of 2 equals 4 to the power of 2, 16. So we can just plug in rational numbers as they are. But 4 to the power of the square root of 2, we have to evaluate, and it is approximately equal to 7.10. This example of exponential functions includes sketching and analyzing these graphs. So, if our first example is f of x equals 3 to the power of x, we are going to evaluate the function by plugging in several x values for the domain. This way, we can see where the graph is headed. So, if we plug in values for x such as -4, -2, -1, 0, 2, 4, and 6, we can see where the graph is headed. So, the domain is -infinity to positive infinity. The range is 0 to infinity. Our y-intercept is 1 because when we plugged in x equals 0, we got y equals 1. The asymptote is on the x-axis, and our end behavior is as x approaches negative infinity, our y value will approach 0. And as our x value approaches infinity, our f of x value will approach infinity. Increasing, this graph will be everywhere. So it is from negative infinity to positive infinity because it is never decreasing on this graph. Our next example is g of x equals 2 to the power of negative x. So since we have a negative x, our graph is always going to be decreasing, which makes our decreasing negative infinity to positive infinity. Our domain is the same, in which equals negative infinity to positive infinity. Our range is 0 to infinity. Our y-intercept is 1 again because when we plugged in 0, we also got 1. Our asymptote is on the x-axis, and our end behavior is as x approaches negative infinity, our g of x value will approach infinity. And as our x value approaches infinity, our g of x value will approach 0. Our next example is graphing transformations of these exponential functions. So, for our first example, we are going to be using f of x equals 2 to the power of x for our three examples to show the transformations being done. So, g of x equaling 2 to the power of x plus 1 is f of x plus 1. Therefore, this graph is just translated up 1 unit from the original graph. Next, h of x equals 2 to the power of negative x. Therefore, this is in the form h of x equals f to the negative x. So, our graph, h of x, from the graph f of x equals 2 to the power of x, is reflected in the y-axis. Our next is j of x equals -3 in parentheses, 2 to the power of x. This function is in the form j of x equals -3 f of x. Therefore, the graph of j of x is the graph of f of x 2 to the power of x, expanded vertically by a factor of 3. Now with k to the x, which equals 4 to the x minus 2, you'll do the same thing as the last equation and just plug in the numbers you want to plug the point set for x. But because it has a minus 2, the transformation will be that it will be down 2 units than the last one. So the asymptote, which is where it will kind of even out, won't be at the x-axis this time. It will now be at -2. So it's still pretty simple. Let's graphing natural-based exponential functions. So we are going to be using the graph f of x equals e to the power of x to describe the transformations. So if a of x equals e to the power of 4x, we know this is in the form a of x equals f in parentheses 4x. Therefore, the graph of a of x is the original f of x equals e to the power of x compressed horizontally by a factor of 4, since the 4 is in the exponent, not before the e. If it was before the e, it would be compressed vertically. So next we have b of x, which equals e to the power of negative x plus 3. This function is in the form b of x equals f to the negative x plus 3. Therefore, the graph of b of x is the original f of x equals e to the power of x, reflected in the y-axis and translated 3 units up, since the negative x is in the exponent and our plus 3 translates the units 3 units up. Next, we have c of x equals 1/2 e to the power of x. This function is in the form c of x equals 1/2 f of x. Therefore, the graph of c of x is the graph of f of x equals e to the power of x, compressed vertically by a factor of 1/2, since the 1/2 comes before the e, not in the exponent. The practice example is t of x equals 3e to the power of x, in which you can see the graph we plot is -3 to +3 for the x values, and we get y values from it. So our graph is always increasing, so it's increasing from -infinity to +infinity. Our domain is -infinity to +infinity, because it's never ending, from the negative x values to the positive x values. Our range is 0 to infinity, because it is never below the x-axis. Our y-intercept is 3, because when we plugged in 0 for x, we got 3. Our asymptote is 0. Our limit is as x approaches -infinity, t of x, it will approach 0. Our limit for x approaching infinity is f of x approaching infinity.
At this point, we need to go backwards because I realized I forgot to put in the audio for one of the slides. So we're going to go back a couple slides to, I think it's this one. And that was my fault. So here we're going to add in the audio that goes with this slide. So I apologize to Katrina and Ellie for missing this one.
To graph g of x to which equals 5 of x, all you have to do is just plug 5 into the calculator and make it to the exponent in which we'll make a table out of. And there aren't going to be any transformations on that one because there isn't any plus or minus or coefficients whatsoever. So in the table, plug in the numbers, and you should be able to make a graph out of the points you get. To graph.
So there was our first lesson for today. A little bit of a problem with our organization of trying to make it work. And again, because we had the break in between, it made it a little bit more difficult. So I thank Katrina and Ellie for doing the best that they could under the circumstances, and especially since we were trying to do this via email, we did the best we can. We will go back the next time I see you and go back and learn some of the stuff and review some of the information that was here, so that way you'll feel confident with what you're doing, and then we'll go on to continue with our book work. So make sure you bring your book when I see you. I think it'll be tomorrow. Have a good night. Bye.